Alright, we're going to be working on proving lines parallel, and we're just going to be using the same pieces of information that we have been using in regards to different types of angles. So what have we got? We've got our corresponding angles, we've got alternate interior, alternate exterior, vertical angles, things like that. So the type of problems you might see is what value of x will make lines L and lines M parallel. And then they might have, let's say we had 2x, and let's say this was 70 degrees here. Well, all you're going to have to do is you're going to look at your picture and you're going to look at the two angles where they have values. Now this angle here and this angle here are alternate exterior angles, and I know that alternate exterior angles are congruent when these two lines are parallel. So since I know these are alternate exterior, they should be congruent. So all I have to do is say 2x. All I have to do is say 2x is equal to 70, which will give me x equal to 35 when I divide by 2. So I know that x has to equal 35 for these to be true. Another type we might have, let's say we had something like this, and I wanted you to tell me what value of x would make these, let's say this was 22, what value of x would make lines L and M parallel? Well, looking at these are corresponding angles, so I know corresponding angles have to be congruent, so I can say x plus 4 is equal to 22, and I subtract 4 from both sides and I'll get x equals 18. So that's just a different one. We can use corresponding angles, but remember, you're not always setting everything congruent to each other. Let's say we had this situation. Let's say we also had lines L and M, and we had, let's say, 2x, and here we had 40. And what value of x would make lines L and M parallel? Well, looking at these are consecutive interior. Now consecutive interior angles have to add up to 180. So I would say 2x plus 40 equals 180. And the difference here was these were consecutive interior, which means they're supplementary. They are not congruent. And if we solve for there, we'll get 2x equals 140. And then if we divide by 2, we'll get x equals 70. So I know x would have to equal 70. So whenever they ask you to, what value of the variable will make the two lines given parallel, you have to look at what types of angles you're given and what do you know about those angles. Are they congruent? Then you could set things equal to each other. Are they supplementary? You can add them equal to 180. Then just solve from there. Alright, when you get into actually proving something, you're going to be using all your different types of angles that you've learned, corresponding, alternate exterior, etc., to prove, again, something that they're telling you to. So here we have, I'm going to make this a little smaller, we've got given angle 1 is congruent to angle 2. Reading that, I'm going to look up here, I'm going to make this angle 1 is congruent to angle 2. And they want us to prove that L is parallel to M. So I would always give myself a statement and a reason. And I'm always going to start with my given. Here angle 1 is congruent to angle 2. That's given. And then second, from there, since angle 1 is congruent to angle 2, I notice those are alternate exterior angles. And if these are congruent, then that means that the lines are parallel. So right from there I can say L is parallel to M, and my reason would be alternate, I'm going to abbreviate alternate exterior angles, and that's just an abbreviation right there. And we're done. Now this was a very simple one. I just wanted to show you how we're using our knowledge of angles and parallel lines to structure a proof. The ones for homework will be a little bit more difficult but that's kind of the idea you're looking at. Okay, also when doing these proofs, you're going to see some things that look a little unfamiliar. So here I'm going to help you out. Now, we've always seen these kind of setup here where we know our alternate interior, our corresponding, etc., etc. But sometimes they're going to give you something that looks a little different. It's really the same thing, it's just disguised. For example, say we had these two triangles here, and these lines were parallel. Now, this doesn't look like anything we've seen before, but in reality, what we have here is kind of the same situation. Notice that these two parallel lines are like these two parallel lines, and this segment going across here is just like this segment going across here. Now we know that alternate interior angles are congruent on these. Likewise, we can say that these angles here are congruent by alternate interior. We can also say these two on the other side, for the same reason, are congruent. So just because it doesn't look like our traditional example here, you can still use the parallel lines to show that different angles are congruent. Let's do another example here. Let's say we had how about this shape here, and we had parallel lines like this. Now, since these are parallel, again, this looks a little unfamiliar, but let's say we had this shape here. All these two parallel lines here are just like these two parallel lines here, and this line going across is the same as this line going across. So here on my right side, I can say that these two angles here are congruent because they're corresponding. These are corresponding angles. So these angles here are the same as these two angles here. I can say that these are corresponding and that these are congruent. It's kind of like, let me draw a dotted line here. If we had this, it's just like it's just exactly the same thing as this picture over here. Imagine we had two parallel lines and one line going through it. So another example of when you have to kind of read into the shape to find your angles, to find your congruent angles. Let's do one more. Let's say we had a shape, who knows, let's say we had a shape like this and like this, and then let's say that these two lines here were parallel. Well, if these two lines are parallel here, I can imagine, I kind of see a pattern. I'm using my parallel lines here, and we're coming across, say I extended this, and I extended my parallel lines here, extended my parallel lines here. We can say that these are alternate interior. These would be congruent, and then also these would be congruent for alternate interior on the other side. So it's a little, it can be a little confusing at first, but as you start to recognize these and play with these, you kind of get an idea for the pattern. So when you're doing these proofs, try to find your parallel lines and find the transversal, the thing that's cutting them in half. And when you do that, it's not too difficult, and you'll get the hang of it, of finding what angle relationships you have and what you can say, what angles add up to 180, what angles are congruent, etc., etc. So feel free to email me if you get stuck on some of these proofs. For your homework, you have one fill in the blank that you're kind of following along with the proof, and then two more that I want you to write up on your own. Have a good idea, even if you can't formally write it. Be ready to present your ideas. Have them written down on paper and bring those to class. All right, see you guys soon.